Welcome to the molecular device webinar on axon conventional electrophysiology. My name is Jeffrey Tang, and I'm the product manager of axon conventional electrophysiology product at Molecular Devices, and I will be your host and presenter today. So let me introduce myself. I got my PhD degree at the Department of Molecular Physiology and Biophysics of the Vanderbilt University, where I studied calcium modulation by mGuar and synaptic plasticity in striatum. After that, I did my postdoc training at UC Berkeley and UCSF, where I studied synaptic plasticity in hippocampus and signal transduction of NMDA receptor, respectively. At 2007, I joined to Molecular Devices as an application scientist. Now, before we begin, let me invite you to submit questions using the Q&A window on the right-hand side of your screen. Now, you can press on the Q&A buttons on the toolbar to expand the Q&A window. And in the Q&A window, you can type in a question and press the send button. Now, let's get started to my presentation. So I have received questions, so let me start it. So today my presentation, the title is Action Potential Analysis in Clampfit. So in the past several years, I have received questions from the customer asking about how to analyze action potential, So this, the following is the frequently asked questions. So how can I measure the frequency of action potentials? And the baseline of my recording is drifting, and it is hard to analyze the spike. And how do I sort the spikes? And my recording is too noisy, and it is hard to retrieve the spike from the noise. So when I do the event search, how can I avoid the larger spike of stimulation artifacts? And how do I perform a phase plot of the dV over dt versus voltage in Clampfit? And also, how do I calculate the cardiac action potential duration at 90% of repolarizations? So today, I'm going to address all those questions. So what we learned today is baseline adjustment and event search, and we can sorting the event. And also, we can also reject unwanted noise and unwanted events. And we can also align the spike. And we can also combine traces from different files. And we can also plot the phase plot. And of course, we can do the action potentials measurements. Now, we got into these features that in the Clampfit that you will learn about manual, baseline adjustment. And we will talk a lot about the event detections of the threshold search. And I know some of you may already use that, and some may not know what is threshold search. And also, we'll use the time shift to align the spike together. And also, we'll use arithmetic calculation, how to plot the phase plot, and also to combine the traces. And we can also use the statistics to do the action potential analysis. Now, for event detections in Clampfit, and it is very important to have a stable baseline. And then you can see from this slide is that the baseline is not stable, and you can see that this portion is drifting right now. So what we want to do is that we need to adjust the baseline so that we can have a stable baseline for us to do the event detection. Now, this slide just shows you how we can capture the spike event in the gap-free recording. You can see there's a trace of action potential here. Okay, now there are two important lines. One is the trigger level in here, or one is the baseline level. So once the event crossing the trigger level, okay, the event will be accepted. So we can see there's so many action potential spikes are accepted or captured in this example. Now we can also, the event in the gap-free mode, okay, can be extracted. okay, and transformed it into a sweep fires. So you can see here, this action potential is basically is recorded under the get free mode, and then we can capture those action potential as a single action potential in a sweep fires. Now, we will show you how to do that in the later part of my presentation, okay? And the later part of my presentation, I will use a Clampfit as the live demonstration to show you how we can do that. And then for the noise and event rejections, so in Clampfit, there are several ways of rejecting unwanted events. Now, which methods should we use depends on the nature of the unwanted events. Now, for example, if the event is very large, okay, have a large amplitude relative to the action potential, that we can use the event rejection method is amplitude. So we can reject the amplitude is larger than the action potential. Now, if the event is very noisy, that we can use the noise rejections. And or the event have the certain lengths, or the event that needs to have a minimum event length, that we can use the event rejection based on the event length. So I will use the following slide to show you the example. Now, for unwanted events with a large amplitude, okay, for example, in this slide, I show you here that you can see a 4 beautiful action potential, but you also see a spike. A huge spike with large amplitude. Now, what we can do is that we can set a rejection level. Okay, we can set a rejection level there. Now, any event above this rejection level that can be rejected. Okay, so that's one thing, that the rejection is based on the amplitude. Okay, I will show you later in the Clampfit how we can do that. Now, noise usually has a shorter duration than that of the action potential. So therefore, for noisy events, what we can do is that we can set a noise duration in milliseconds to reject the event if the duration is shorter than the defined noise duration. Okay, so basically, we can set up a noise duration. Now, if the noise, the duration is shorter than the one that we define, that also will be rejected. So in this case, so the noise duration can be set so that to reject the noise spike. So this 3 spike, because the duration is very short compared to the action potential, so they get rejected. Now, we can also set the minimum allowed duration to eliminate short events, and also we can set maximum allowed duration to discard events that are too long. Okay, so in this case, I still use this example, is that those spike because the duration is very short, so that we can set the minimum allowed duration. If the duration of those spike is less than the minimum allowed duration, they will get rejected. Okay, so you can see only this action potential, okay, is accepted. Now, then we will talk about the peak alignments. So in this example, in this slide, you can see this is two traces here. And then this is basically is a current injection to evoke action potential. Now, you can see this first spike of different traces. Right now, they are not aligned together, but we can align the first peak together, okay, of these two traces, as shown in the right-hand side. Okay, now I will show you how to do that. And then we can also, and I will also show you how to combine traces from different file. For example, this traces is from file A, and then this traces from file B. Now we can combine these two traces together to get this figure. And then I will also show you how to, implement this phase plot. So by plotting the dV over dt versus voltage. I think that is very important for people studying the excitability of a neuron. Now, at the end, I will also show you how we measure for the cardio action potentials. For example, the resting membrane potential here, and then the action potential amplitude, and what is the action potential duration for the 50% after vaporization or 90% of after vaporization. and also we can determine what's the maximum slope of the depolarization. Okay. Now let's look at the main theme of today about the event detections of the first source search. You can see in here in the right-hand side. I will spend quite some time to talk about in each features in these boxes. Now, for the category, okay. So basically, each category represents a unique search criterion, and there are up to 8 different criteria, different categories. So for example, for today, we probably only use 1, but you can up to 8 different categories. And then the positive and negative going describe the location of peak relative to baseline. Now, for example, action potential is a positive going event, so you should check the positive going. And then another important feature is that you need to bring the markers. 2 important markers is one is the trigger marker, and it is the baseline markers. So we can set the baseline and trigger marker by moving this line. Okay, the moving the line. 0 is the baseline marker, and the 2 is the trigger marker. We can move the line, or we can type the number here. Type the number in here, the baseline, right? And also we can type the number here. Okay. Now, if the event cross the trigger level, the event will be accepted. Okay. This all 4 in theory will be accepted as a event. Now, we also have okay, this show you here. Now we also have another feature is called rearm. Okay. Now rearm is basically a fine-tuning in event search. So the start of an event is determined by the crossing of the trigger level. So for example, in here, now here is the trigger level. Okay. Now the upper panel, I don't use the rearm, and the lower panel, I use the rearm. Now, the start of an event is determined by the crossing of the trigger level. So in here is the start of an event. Now, if no arming level is selected, for example, in this case, the next crossing of the trigger ends the event. So when the event comes to here, that will be the end of the events. Now, if you specify a value for the rearm level, for example, here we put a delta 10 minimal above the baseline. Okay. Now the crossing of this level will indicate the end of the event. So right now you can see the ending of the event is prolonged compared to this one with no rearm, without rearm, and this one with rearm. Okay. So in this case, that you will change the duration of the event length. Now, I've been talking about, if you remember that we talked about there's 3 different ways to event rejection, to reject some unwanted event. Now, this is something that you can set in the Clampfit in the first source detection, first source search. Right? In this slide, just show you an event rejection is based on the amplitude. So let's just like I just repeat a little bit again, so that in this 3 spike with a huge amplitude relative to the action potential. Now we can set a rejection level here. Now we know that there's a baseline level, trigger level, and we can also set a rejection level. So any event above this rejection level, in this case, this 3 spike, will be rejected. Now I also talked about the noise rejection in the previous slides. So in Clampfit, in the first source detection, that basically we have the noise rejection that I'm talking about, that you can set the number in milliseconds. As we know, the noise, normally the duration of the noise is very, very small relative to the duration of the action potential. So in this case, I set 1 millisecond. So if the noise duration is less than 1 millisecond, that will be rejected. So you can see here, if I don't check the box of noise rejection, now all those spikes will be accepted as the event. Now, if I set 1 millisecond here, now all those 3 noises spike will be rejected. Now, now we talk about the pre-trigger and post-trigger. Now, the pre-trigger and post-trigger length help to extract a segment of trace before and after the event. Okay. Now, for example, in this case, in the right-hand side, I put pre-trigger for 5 milliseconds and post-trigger for 20 milliseconds. What that means is that, what they mean is that the 5 milliseconds before the trigger will also be extracted, and also 20 milliseconds after this trigger, and also will be recorded. So that is the way that we can set the pre-trigger and post-trigger. And this basically, you can see the length of the event will be recorded longer than this one without, the pre-trigger and post-trigger length. This one, we don't set anything for the pre-trigger and post-trigger length. Now, this one of event rejection is the third method. Do you remember that? The first one is about the amplitude. If the amplitude is so big that we can have the rejection level. The second way to reject the event is by noise, duration. Now, this one is the third way to reject the unwanted event. That is basically based on the minimum allowed duration and the maximum allowed duration. It depends on what you put it here. Now, in this case, in this example, I put 1 millisecond is for the minimum allowed duration. What that means is that any event with a length duration less than 1 millisecond will be rejected. So in this case, if I don't set any minimum allowed duration, now you can see all this spike and also these 3 tiny spikes, will be accepted as a event. Now, if I set the minimum allowed duration, in this case, because the duration of those small spikes the duration is very small, so that they will all get rejected. You can see the duration of those spikes is less than 1 millisecond. So I mean, in the real case, of course, you will have different, different types of different shape, or different amplitude, different duration of unwanted event. So you can play around with this number, that you can get rid of those unwanted events. Now, this slide just shows you something that we can manually select the event, in the Clampfit, in the threshold detection. Now you can see that we have the accept, reject, and suppress, and accept plus test. So in this case, the first 2 spikes, I say you can click manually accept, so they will accept it. I will show you later with the Clampfit demonstration. And this 2 spikes is rejected. You can see there's no denoted, right? In this case, you've accepted. You can see the small diamond here, and this is rejected. And if you hit this button, this will be suppressed. The suppression will be, you can see the gray diamond. These 2 spikes, I choose to suppress. And the last 3 spikes, I select for the accepted, and also I keep a tag there. And the event, the state of the event can be reported in the event result sheet. So you can see here that accepted and also accepted and tag will be seen in the result. Now, if you also want to see the suppressed event, now you need to go to the event detection, show suppressed event. They will also show it to you. Now let's talk about the phase plot. Now you want to plot the phase plot. Now you need to select the trace first. Example for this one is the beautiful action potential. And after this one, you need to go to the transfer trace to transfer this line as a text format. So they can see that is time, that is the amplitude or the voltage. And then in this column, that you can calculate the dV over dt in column arithmetic function, like column C equal to differentiation of the column B. So you can have this number, and then after this one, you can plot this one as the y-axis, this one is x-axis. So you can plot this graph. Okay. Now let me go back to the turn to the Clampfit. So I will do the some demonstration to you how we can do all the things that I just mentioned to you. Now, first of all, we want to study how to do the baseline adjustment. Okay. Now I have something here. Okay. Now I get out the file. Okay. So, and then you can click this one. You can see the auto scale. Now this one is you can see the baseline is not is drifting. Now if I don't want to see these two panel, what you need to do is go to the property, and then I want to hide these two signal. Right. So now you see more clear right now. Okay. Now what I need to do is that I want to adjust this baseline. Now before that, you need to know that what is the resting membrane potential? Okay. Now the resting membrane potential is about minus 55 in here, right? Now this is the get-free mode for the action potential recording, right? Now what I need to do is that I need to go to analysis and go to adjust for the baseline. So I want to adjust manually. Hit OK. Right. Now you can see there's a purple line here. Now what you need to do is that you just drag the line, and also you can add the point. Okay, at any point to the line, and then you can also move the point. Okay. Right. The more point that you add, will be more accurate. Okay, now you can add more. And you can add more here. Okay. So I think it's pretty good right now. Of course, you can put more, more point. Okay, can give you more better result. So after this one, I just hit OK. Now you can see the baseline is quite flat right now. Okay. Now of course you see the shift. The baseline right now is at 0. Now what you need to do is that you can go back to adjust baseline, because you already know that the resting membrane potential is minus 55. Now you need to type 55 and hit OK. You can subtract the fixed value. Now you can go back to here. Now after this one, now we can do the first search. Okay, search for the event. Okay. Now let's do the second experiment right now. Okay. Now let me open another file. Okay, I want to do one more time. We did this for the auto scale y-axis. Now you want to hide these two panel, go to properties. All right. Now I want to do the event search. Okay, now this is basically a long recording with 100 seconds. You can see a beautiful action potential here. Okay. Now what I want to do is that you go to the event detection, and then you go to the first source search. Now you can have this window. Okay, this is what I told you earlier. Now that is basically, I've said that they have the category. You can have a category, and this basically is really helpful. I will talk about that if I have time. Okay. Now you have the baseline in here, and then also you have trigger baseline. Now you can move this line. Okay. Or you can type the number here also, and also you can move this line as a trigger level. Let's say here, I put it here. Okay. Now you can set pre-trigger and post-trigger. Okay. And then I don't set any event rejection because I don't see any spike here. I don't set noise rejection. I don't set it here. I don't see the, if I set the reject here, you can see I don't need to in this case. Okay. Now, and then also you can, for the full trace, you can use a cursor. Okay, if you want to hide, you want to just analyze this portion, and you just need to select the cursor 1 and 2. Now I use full traces in this case. Then I hit OK. Right now they start to search. Okay, and here is basically it's very important icon. Now I talk about this one, and the good thing about the Clampfit is that if you go to here, it will tell you what is that. Okay, you can go to non-stop. Okay, non-stop. Okay, in this case, you will see they keep searching for the event. In the meantime, you can see the event viewer. So basically, they are sorting the amplitude, sorting the action potential here. Now it's done. Okay. Now we have 810 events here. Now in this one, you see there's a tail. Probably is because at the end, okay, the last one. So this one, you can easily to have, you can delete this one or this one. Okay, reject it. Okay, hit OK. We don't want that. Now you have this beautiful sorting of the event. So right now, 809 events right now is in this one. Okay, so in this file. Okay. Now you can save. You can save this one. Okay. Now I show you right now event search and also this sorting. And you can save as a file. You save this one. Okay. Of course, I already saved it. Okay. So now I just cancel it right now. Okay. Now, then right now, if you want to open this file, okay, this is the file event. If you want to open it, okay, now, so you can see this, the event sorting here. Now, you can also take the average trace here. Okay. Hit OK. I want to average the trace. Hit OK. Now you can see this is a beautiful action potential. Okay. Now I want to use this example right now. Okay. Okay. To show you now. Right now I already done with the event search and event sorting. Okay. And now I want to show you how to do the phase prompt. Okay. The phase prompt. Now I want to use it to slice. Now, what you need to do is that you need to go to the transfer trace. Okay, transfer trace of this action potential. Okay, what you need to do is that because you only need this one. This is the average one. Hit OK. Now you see this one is the time, and this is the trace 810. Now, this one is basically is the voltage. Now, you can format the column, rename it. Okay, this one you can rename it is the voltage. Okay. The next one I want to name it, this column is dV over dt. Hit OK. Okay, I showed you before, transfer traces, and now you can use this one, use arithmetic in a Clampfit to calculate the differentiation of this column in here. Now, what I want to do is that you can use column arithmetic in here. Now, column C equal to differentiation of column B. Now, basically, you can see the function here. We have a lot of different functions. You just go to here, okay. Or basically, you can also type it. Okay, you can see column C equal to, you can see the function, and you can type column B. All right. Then for the full column, then when you hit OK, you can see here. This will give you this dV over dt. Now, if I want to plot dV over dt versus V, so this will be the x-axis, and this will be the y-axis. Just click here. And I can easily go to here, create a graph. Now you can see there's a phase plot here. It's very beautiful. Okay, phase plot. All right, let's close this one. Let me also can clear all the sheet. Okay. Now, the next experiment I want to do is that how we can reject unwanted noise or event, okay, to do some unwanted event rejection. Now, let me go to bring out this one. Now, let me redo again, okay. Click here, and then if I don't want to see these two, I want to hide those things, these two column panel, go to here. Right. Now, in this case, you can see, okay, because I modified the data, so that you can see I put some spike here, okay. Now, the spike, of course, I make this noise, I know, that's why I know where it is. But one thing I want to share with you, how you can move the cursor more efficiently. For example, you can right-click this cursor one. I want it to go to 21 seconds. They will go to 21 seconds. I right-click this one, go to 22 seconds. All right. All right. Now, if I can enlarge this one. Now, you can see here that there's 3 noise spikes here. 1, 2, 3, and 4, 5, 6. These 3 spikes have the amplitude is very large relative to the action potential. The action potential here, and this 3 spike is about the same height of the action potential. Okay. Now, I want to show you how we can use this one. Okay. The first method. Okay. Okay. Now we go to. Okay. First of all, because I need to quit the event detection because I used it before in the earlier file. So now I need to first search. Okay. In here, you still can see that there's a baseline, right? And this is for the trigger, right? Now, if I do this one right now, I set pre-trigger 5 milliseconds and post-trigger 20 milliseconds, okay? All right. So if I do just 1 and 2, because I don't want to spend the time, I just want to analyze the event between cursor 1 and 2. Now, if I hit OK, now you will see all these 6 events will be recorded, okay? But actually, we don't want them, right? So let's do something. Let's set a rejection level there. I set the rejection level in here. Any event about this link will be rejected, okay? And the rest is the same, okay? Now, what I need to do is that hit OK, and I hit redo it, restart it. Delete existing data before restarting, yes. Now, we can hit this one. You can see these 3 will be rejected. But however, because this 3 spike is very, close, in terms of the amplitude, they are relatively, the same as the action potential. Okay, so this one rejection level doesn't help to remove both of those, right? Now, what we can do next is that we can use, as you remember that, we can use the noise rejection, okay, noise rejection. Now, you can bring out this catalog, bring out this dialog window. Now, I don't want to use, I can use the rejection. Now, I can also set the noise rejection here. Now, I know that the duration of this 3 noise is very small, okay, all right, very small. If we enlarge it, for example, if we enlarge it, you can see there is action potential, and this is a spike. The duration of this spike is very, very small compared to the action potential, right? So what we can do is that, okay. So what we can do is that I set 1 millisecond, hit OK, and then we can redo it, right? All right. Okay, just want to give you guys a better view. I'm sorry. All right, here. And then I click here. You can see this, because this 3 is rejected by the rejection level, and this 3 is rejected by the noise duration. All right? So I show you the second method, how to reject noise and unwanted event. Now, the last method I want to share with you, I mentioned that you can also set the minimum allowed duration. Okay, instead of use noise rejection, I can also set something in here. I can set minimum allowed duration. If the event duration is less than 1 millisecond, and they will be rejected. Okay, let's see what happened. Okay, now I still use the rejection level to reject this 3 huge spike, and I want to use this minimum allowed duration to reject this 3 smaller spike. And then I hit OK, and then I will do it. Now you can see here, this 3 spike is rejected by rejection level, and this 3 spike is rejected because the minimum allowed duration you set there is 1 millisecond, and this 3 spike, their duration is less than 1 millisecond. So I hope that right now is very clear. I show you how we can, during the event detection, the search, that you can avoid those events, unwanted events. For example, sometimes people say that they have a huge, stimulation artifact before each pulses, right? They don't want that. This is the way that you can use to get rid of those, avoid those events. All right. Okay. Now the next one I want to share with you is that. Okay. Now I need to. Okay. Now I need to. Okay. Quit event detection because I'm going to open another file. Now this is for the gap-free mode. And how about if I have to inject the current, evoke the action potential? Okay. Now if I bring out this one, okay, this one will be evoked action potential. All right. For example, in this case, okay. Now in this case, it's a little bit complicated because it's not spontaneous. The baseline is different. In this case, we still can use, event detection to find those, action potential. Okay, the frequency. Okay, frequency. Okay, you go to step switch. You can see here. Now we can have the spike, right, in here. So what we can do is that we can also select those, find those frequency. Okay, we can set the cursor 1 and 2, and then we can go to the event detection. Now again, so we don't want to have the rejection level. So this is the baseline. Now the baseline right now, you can set any baseline is fine because right now you just want to get the frequency of the spike. Okay, set up here. I don't need the noise. I think it's okay. I don't see the noise, right? So I can say hit OK. Right, and then non-stop. Okay, now, of course, in this case, what we need to do is that because I just set up to the one traces, so we need to okay, select all the traces. Okay, hit OK, hit OK, and then we can restart again. Yes, and then we can see now. Did we search all the action potential in different traces? Okay, and then if you go to result, now you will see all those data. For example, the only event is found, the first event is found in the trace 14, 16, 17, and 18. Okay. Okay. So okay. So go back to, let me see here. Baseline, whatever. Okay. Now the next experiment demonstration, I want to show you how to combine the traces right now. How to combine the traces. Now let me close all right now. Right. No trace, right? No. Okay. Now, in order to show you the combined traces, I need to pull out two documents. One is for this one, and one is for this for the AP, and this okay, there's two. I have two very good Carlier action potential. Now, what I want to do is that I want to combine these two traces. You can click this one. You can see these two traces together. Okay. Now, I want to combine these two traces together. What I need to do is that in here, okay, now you can go to analysis. Now, in order for you to combine this trace, the two traces has to be recorded in the same condition. For example, they have the same duration, the same sampling rate, okay. And then in here, what we need to do is that go to the analysis, go to arithmetic. Right. So first of all, okay, we need to clear this one first. It's okay. Now you want to add a trace. Okay. Now because only one trace is right now for each one, so you add one trace will be traces 2. Okay. Add traces. Sorry. Okay. Okay. Now you see the trace 2 is here. This trace. Okay. Now you need to define what is trace 2. Trace 2 is equal to, okay, equal to which trace? Because you want to combine this control, this one, to here. So what you need to do is that you need to specify the window. That will be the control, AP, and this one, all right? And then hit OK. Now they will come to here. All right. Now you can see here the two traces are combined together. Okay. Now let me do it one more time. In this case, in here you want to combine these traces to here. Okay. Move the trace VTP AP to here, right? So what you need to do is that go to analysis, arithmetic. Okay. So we need to clear it out. It's fine. You add traces. Will be the second traces. Now you can see this is traces here. Now you need to define what is trace 2. Okay. Okay. Trace 2 is equal to, okay. Now you need to specify the window. That will be this window, and then here is 0. Right. Now you have two sweeps right now. The first sweep is this red one. Okay. Hit OK. Then you will see the trace will move from here to here, combine the traces. All right, so I think I show you how to make the trace combined. Now, the next one I want to show you, okay, close all, right. Now, the next one I want to show you is that how to make the pit alignment, okay. For the pit alignment, I need to bring out this data to you, okay. Now in here, so what we need to do is that now, and then I need to select 2 sweep to show you how we can do that. I know that 21, and then you want the 2 sweep, you can select 21, and then you click the control, hit the control button, and then click 26. Now you can select 2 traces. Okay, sweep 21, and then you select control, sweep 26, hit OK. Now you can see here that is the 2 traces. Now the first pit, they're not aligned together, but I want to make them together. I want to align the first pit of the action potential of each traces. Now what you need to do is that you need to use the cursor, bring it to here, 1 and 2, okay, between the first pit of the red traces, and the first pit of the black traces. Then you go to the time shift, all right, and then you align pit, and then the region to search is cursor 1 and 2, between 1 and 2. Of course, you can select, okay, but I already set 1 and 2, and then you need to select the traces, 21 and 26, and then hit OK. All right. All right. Now, when I do that, you can see the 2 traces, the first pit, they are aligned together. Now you will say, oh, what happened right now? The x-axis, the trace is stripping right now. What you need to do is that you go back to time shift. Now you can, in this case, I type 300 milliseconds to the left. Okay, to the left. Okay. When I do that, now you can see the ship is stripped back to the place where they are, or you can move move to left and right. Okay. So right now you can see the 2 traces. They are the first bit. They are aligned together. All right. All right. The next experiment I want to show you is that how we can analyze the cardiac action potential. Now, the one that I want to bring it out will be this one. Is this action potential is basically obtained in the rabbit. Okay. Now again, if I want to hide this panel, go to the property. Right. Now you can see it is a beautiful action potential. Okay. Now if I want to determine, like I said, the resting membrane potential, and then I want to determine the amplitude, action potential amplitude, and also the APD, action potential duration, 50% and 90%, and also the maximum slope. Now what you need to do is that use the statistic, but before that, you want to use, bring 1 and 2 as the baseline, and then 3 and 4 for the search region. Okay, this setting. Now you go to statistics. All right. Now the baseline region is between 1 and 2. Search region is between cursors 3 and 4. Okay, so you can see here. Now you check for the pit amplitude, and then you can check for the half width. That will be 50%, APD 50%. And then you can also maximum rising slope. That will be the maximum. Okay, will be somewhere around here. And then you can also measure for the baseline. That will tell you the resting membrane potential. And then you can also measure for the APD 90%. That means you can measure the rise time from 10% to 100 to the pit. And also you can measure the time, okay, from 100 from the pit to the 10% from the pit. Okay, this will be the rising time. This will be the decay time, and this time add together will be the APD 90%. Okay. Now when I do that, hit OK, and all the data will be shown in the result. So you can see that is the pit value. Okay, this is for the half width. And then you will see this is the baseline. This is for the resting membrane potential. Okay. So you can see the rise time and the decay time, right? So basically, this will add together, will give you APD 90%, or this number is the APD 90% of vaporization from the pit to the 90 to the 10% of 90% of the pit. Okay, so the last experiment I want to show you is that, okay, the last experiment I want to show you is how we can accept and reject and suppress and accept the tab. Okay, so I want to bring out this one. I want to bring out this spontaneous, right? So again, we can go through this one. How we can hide it? We can just go to here, right? And you can, like I said, you can set up here, go to the 21 second, and this one go to 22 second. Okay, now I just enlarge this one. Okay. All right. Now what you need to do is that, again, you can have, go to this visual search, okay? And then right now, I mean, you have the baseline trigger and the pre-trigger and post-trigger, right? So cursor 1 and 2, hit OK. Now at this, all right. Oh, I see. I need to, okay. In this case, I need to, because the trigger level and the baseline level is not correct set. Okay. Now what I need to do is that bring down this one, bring it back to here, this baseline, here. All right. So hit OK. Now in this one, what you can do is that instead of we go to the auto, non-stop, you can also use this one manually. You can say accept it. Okay, accept. You can see there's a small diamond, and this one accept it. And then you can, okay, accept it. Now these two, let's reject it. Okay, you can reject it. You see, they will be rejected, rejected. And these two, let's say we can suppress it. Okay, suppress it. You can see the gray diamond. And these three, let's accept it and tag it. Okay, so you can see there's a huge diamond here, right? So after you do that, you can go to the window, result. Now you can see the state, because right now, okay, in here you can see we have only 5, 1, 2, 3, 4, 5. 5 accepted, 2 suppressed, 2 rejected. Okay, now you can see in here, only show you the accepted one. Now you want to see the suppressed event, you go to the event detection and go to the show suppressed event. Now they will show these 2 suppressed event here. All right. And also, the good thing about the events that the visual detection, where you can have all those very good, for example, event statistic. You can have all those events, for example, the pit amplitude, time to pit, all those event area or decay slope, rising time. It's very good information here. Okay. Right. Close. And you can also go to the define graph. Okay, for example, you go to the graph here, fast graph. Right. So you can, for the scatter plot, you can select, for example, okay, x-axis for the time of the pit. Okay. Hit OK. And then y, you can set the pit of the time, the pit amplitude. Hit OK. So you can hit OK. Now you can see all those plots. It's very easy, right. It's very simple, right. And also you can go to, even though you can also go to define graph. Okay. All right. So I show you the fast graph. Okay. So anyway, so let me go back to my presentation here. So I think it's time, so it's almost 9 o'clock. So I think this will be the summary slide that I will show you how the baseline adjustment and do the search event and sorting the event and how to adjust the noise unwanted event based on the amplitude basis or the duration basis, and how to align the spike, combine traces, and phase plot and action potential analysis. So thank you so much. And then we have time, a couple minutes for the Q&A sections. So at this point, I have Jackie here. So Jackie, do you have any couple questions there from the audience?
Yeah, there's one in particular that many people asked was, will they have access to this webinar in PowerPoint after this is over?
Yes, so that's right. So basically, let me pull up this one, okay? So after today, maybe a couple of days later, so so you can this webinar will be posted in this website, molecularwebs.com. Go to this website, and then you select for the list of the event, and then you can select for the getting the most out of the pCLAMP program, and then you will see today's presentation is action potential analysis. Okay. Right. What's next?
All right. And then one other question is, it's easy to adjust the baseline for spontaneous action potentials in the gap-free recording.
Right.
So how would you adjust the baseline and current injected evoked action potentials acquired in the episodic stimulation mode?
Oh, wow. This is a very good question, okay? This is a very good question, okay? So let me tell you something, okay? Let me tell you something, okay? Yeah, that's right. It's very easy to adjust the baseline when you do the gap-free mode in the gap-free recording, right? But what happened is that if we do, okay, let's say here, okay. If we do, for example, let me pull this one. Now for this one, okay, how we can do the baseline adjustment, okay. Now what I want to say is that, okay, there's two ways. So I'm thinking there's a two-way that what we can do, okay. So the one way is that, okay, do you remember that what I told you before? Now we have in here, okay, we have different category, okay. Now we can set different category. I mean you can in each category, right? You set for the baseline and then also for the trigger, okay. Of course, in this case, if you look at the sweep duration, okay. Now you can easily to see that, you know. Okay, you can see which sweep they start to have. For example, in here, now 14 sweep, they start to have action potential, right? Now you can use this category, okay, to define the baseline for these traces. And then you can select another traces, and then you can go to the category 3 to define, because the baseline will be different in each category. And then you can select, you can define for the baseline and the trigger for each category. Okay, that's one way that I'm thinking that could be do. All right. The other way that we can do is that, we can go to the step, okay, set all. Now we can make this sweep file, okay, because there's basically we can, this is a sweep, you know, with traces. We can make it to the continuous. Now in the continuous, that we may be able to, you know, to adjust the baseline, you know, right? So we still can do the baseline adjustment, right? Right, we still can do the baseline adjustment to adjust those baseline, okay, the way that I showed you before. I think there's the two way that we can use different category, or we can make this episodic stimulation fire to a sweep traces to one continuous traces. All right. So I think the time is already past now o'clock. So what I want to say is that so I would like to thank you everyone to attend to this webinar.